Hello everyone, welcome back to another Sudoku. Today we're going to be looking at Chain Grid by Tyrgannus. Standard XV rules. These cells add to 5, so they could be 1, 4, or 2, 3 in any order. And if there's an X, then it must add to 10. Additionally, these white dots have to be adjacent, so you could have like 1, 2, 3, 4, and so on. This is a extremely full grid to start. Just gonna highlight all the V's. Now in this middle row we've got 4 different 1, 2, 3, 4s, so this has to be adjacent, so it must be a 5. You can't have a 5 in an X, because then you would need 2 5s. So all of the X squares that are connected to B squares in any order must be 6, 7, 8, 9s. Which sort of chain reactions up into another small number. Right, this 5 is adjacent to something. That can't be a 6, so that must be 4, 1. Just leaves behind a 2, 3 pair. Now those have to be 2, 3, because it's either 3, 2 or 2, 3. 2, 8 or 3, 7. Okay, there's no knowledge on if the white dots are negative, so I think there could be a 6 in one of these spots. But we do know that all XV clues are given, so that should be a negative constraint. So I can't have a 9 here, for instance. Or 6 because of the 2, 3. 2, 3 pair in this box. This is all sort of just working out. Yeah, this is interesting how the puzzle's progressing. So many interconnected pieces. Like these two are mirrored. If this is a 4, then this is a 6 and this is also a 4. So it sort of chain reacts over there. There can't be a 5 in any of those spots, so the 5 in that row is limited. 5 up here is also limited. 2-3 pair, right? And here. And this space can't be a 1 or 4. So this must be a high number. This is the low number that holds them together, which gives us another 1, 2, 3, 4 quad. Which is interesting, although I don't see how it's useful yet. Six in this box is somewhat limited. Not crazy, though. This must be next to 7 or 8. Huh. This 1, 2, 3, 4 triple here. Might be too tired for this one. We've got 3, 1, 2, 3, 4s here. There must be 1 here, so the rest is all high numbers in this row. 5 or above. If the white dot was a negative constraint, then 6 in this box would have to be here. But I think I'm gonna keep assuming it's not, because I feel like if I'm wrong about that, it's gonna be bad. So we have 1, 2, 3, 4 done here, and this can't be a 5, so it's gotta be a high number. We got 1, 4, 2, 3, so actually the rest of the numbers here must be high. That row's kind of done, not really. Right, this 2, 3 pair. Means that can't be a 2, 3, that's a 1 or a 4. So now these connected cells can't be 7 or 8. Be a 6, 9 pair? Almost. That can't be 2 or 3, and that can't be... Oh yeah, here we go. 7 or 8. That can't be 6, 9. I think this 1, 4 pair means that this can't be a 1, 4 pair. Because if this were a 1, 4 pair, this would be valueless. So that's 2, 3, which means that the numbers that connect can only be 7 and 8. So that's a 7, 8 pair in here now. This is all interesting, but will it get me anything? Yes, because of this one. This one means that's a 4, that's a 1, that's a 4. This is a 6. This is a 9. That's a 6. This is a 1. This is a 9. This is a 1. This is a 4. So now this is a 2, 3 pair. which I knew because of the 7-8. Oh, there's a 2-3 pair in here. So we got 7-8 and what else to put in these spots? Four. So this is the 4. This is a 7-8 pair. This can't be a 1, so neither of those could be 9s. 2-3 pair means everything else is above 5. Don't know how helpful that is. Also don't know how to notate that. 6 can't go next to 4, so in this box this is a 6. Which makes that a 4 and that a 6. Sec, I gotta add on Discord. Huh. This 4 means that this can't be a 4. Now this can't be a 1. Not crazy exciting there. And 7, 8, 9. This 9 and this box is restricted. If I put a 9 in either of these spots, it'll need a 1 to complement it. So the only 9 place 9 can go is up there. This box needs a 2-3, and the only place it could go would be 1, 2, 3 in this X and 1, 2, 3 here. I phrased that in English, but it sounded really weird when I said it. I need 1, 2, 3 pair. Anyways, so one of them is in there and one of them is in here. So the one in here I can worry about. Because it forces another 2-3 pair there. Is that useful? Yes, it pairs up. So there should be another 2-3 plus 7-8 pair. Don't have any 7-8s in the grid yet. How do I figure out the order? Alright, 4 is in this box. Let's go here. So we get 4 and 1. Got 1 in here. 5-1 pair. Hopefully that doesn't get lost. Interestingly, this can now no longer be a 9. Yeah, because the XP negative clip. So actually none of those could be 9s. Very nice. So that's a 9 forest, and that's a 9 forest. We might be able to get all of them already. Five, 9 pair, pretty nice. 9 in this box. Right, I can't use 1 as the lower bound here because of that. I also can't use 2, 3, so there must be a 4 in one of these. This can't be a 4, so this can't be a 1. So that's a 1-4 pair now. Oh, so now the only 5 left is here. Is that right? Looks right. Has to be 5 in one of those spots somewhere. And there has to be 5 in one of these spots. So this isn't a 5, this is a 5. Either a 5 here or here, but I don't know which way yet. 7 and 8 left to place. As well there. So we got 6 and 9. So one of these, 7, 8, and one of them is a 2, 3. This can't be 1, 9 or 4, 6. So that's also a 2, 3, 7, 8 pair. This one can't be a 2, 3. So it's gotta be a 7, 8. That's a 2, 3. Thinking I could do something clever with the negative constraint with this 6, but we've already got the 4 next to it. Two, 3. Well, we finished up most of the 2, 3 pairs. Can't be any more 2, 3s there. There's so much to look at, it's hard to know what matters. The 1 and the 9 have to end up being offset because of the negative constraint. These 2 are opposites, and these 2 are opposites. Thinking 5 is the answer, but I can't make any progress there either. Although maybe I can. If you combine 5 and 6s, you can get some good stuff. What 6s are on the board? Let me highlight them. Oh yes, this has to be a 6, so that has to be a 7. This must be a 3, that's a 2, that's also a 7. This 3/4 is 2, 3, 8, 2, 3, 2, 3, 2, 3, 7. Two, 8, 2. 3, 2, 3, 2, 8, 7. This needs a 1. 1, 2, 3, 4, 5. Needs a 5. I don't know where that goes. Needs an 8. Maybe I'll have more help in this box. 1, 2, 3, 4, 5, 6, 7, 8. That's an 8. That's a 7. One, 2. It's gotta be 3, 7 in here. I've got 1, 2, 4, so this is also 3, 7. Which leaves 5, 6. And this 4 rolls out a 6. That's the 5. That's the 6. That's the 5, and that's the 6. Now this 2 is connected to an 8 because of the X roll. There's a 4 in here, so it must need a 6 as a partner. Three and 2 would need a V, so that's a 7. Why is everything so loud? This row's done. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, 7, 8. I paused there because I thought it was 5, but no. Alright, let's fully notate this real quick. 1, 2, 3, 4, 5. And 8. And this row needs also 5 and 8 and 7. That can't be 7. Let's see how to finish this. 2 restricts 8, which leaves a 5, 9. No, not 8. 1, 2, 3, 4, 5. This does need 8. What? Okay, yeah, so that's where the 8 goes. All of these need a 5. One of these is a 9. That can't be a 7. That can't be a 7. Okay, that's just normal Sudoku then. Just leaves 5, 9 and 5, 8. This can't be an 8 because of the 2s. So that's how you finish it. And 9 can't be next to 1. Alright, pretty good puzzle here. think I was a little bit slow to track some of these logic, but definitely the chain reaction is a lot of fun. Very cool puzzle. I'll see you on the next Sudoku. Thanks for watching. Be sure to like if you enjoyed. I'll see you on the next one.